This is the oxidation reaction of an alcohol. And in this case, we have a secondary alcohol. So we're doing oxidation, and we have oxidizing conditions. Those oxidizing conditions are represented by the O in brackets above the arrow. So we have our secondary alcohol, and we can name our secondary alcohol. We want the alcohol to have the lowest number possible, so this is 1, 2, 3, 4, and we would call this 3-methyl 2-butanol. 3-methyl 2-butanol. Remember, the name butanol comes from butane. We drop the E, and because it's an alcohol, we add OL to make it butanol. The oxidation of a secondary alcohol makes a ketone. So we're going to draw our ketone product. Now, the carbon chain will remain the same. So I'm going to draw the carbon backbone. 4 carbons. We have a branch, and where the oxygen of the alcohol is, we now will have a double bonded oxygen, and we now have a ketone. We have a group on this side of the carbon-oxygen double bond and a group on this side of the carbon-oxygen double bond. We're going to name this ketone in a similar way to how we named the alcohol. So we're going to number so that the ketone has the lowest number, 1, 2, 3, 4. So this is going to be based on butane again. However, we now have a ketone, so we're going to drop the E, and we're going to add -one. So this will be called butanone. We then need to say where the ketone is. We see that the ketone, the carbon-oxygen double bond, which is the carbonyl that makes this a ketone, is at carbon number 2. So we call it 2-butanone. In addition, we still have our methyl group, and so we say 3-methyl 2-butanone.